Hi, and welcome to this section of the Advanced Algebra Tutor. And in this section we're going to tackle inverse functions, or inverses of functions. There's an inverse to everything in life. Multiplication, the opposite of it is division, and addition, the opposite of it is subtraction. So the inverse function can sort of be seen as the opposite of whatever function you were talking about to begin with. So if you were given a function, you can calculate its inverse, and that can sort of be seen as the opposite of that function. So let's just look at kind of an example here and show you what an inverse is here by actually working something out. If you had a function and you knew that f of 3 was equal to, let's say, 7, okay, it's just an example. I don't know what the function is. All I know is that f of 3 is 7, okay? Then the inverse, written as f of -1 like this, okay, that would be called the inverse, has the property that f of 7 is 3. Okay, so that's really important to tackle and to understand. If you have, this is the inverse function, if you have a function so that when you plug in 3 you get 7, and that function is something, then you can always, almost always anyway, define an inverse so that if you plug in 7 you get 3. Okay, so this is a different function. It will look different, but it's related to the original function. I'll show you how to find that in a minute. Okay, so similarly, if you knew that f of 1 was equal to 3, then you would know that f inverse of 3 was equal to 1. And you would know, for instance, f of 101 is equal to 5. Then you would know that the inverse function evaluated at 5 would be 101. So it's a real simple thing here. And then in general, because of what we're talking about here, the inverse function evaluated with f of x, so f of x plugged into the inverse function is going to be equal to x, and f of the inverse function is also equal to x. And these things right here are called the cancellation properties of inverses. Okay, and what does this mean? This is important for you to remember here, okay? If you take a function, okay, and you plug it into its inverse, you're going to get back x, because you can see what's going on here, like in the case above us here. If f of 1 is 3, then f of inverse evaluated at 3 is 1. So if I take the opposite function and evaluate it in its inverse, I'm just going to get back x. Okay, so it's sort of reaching in and reaching into what I've evaluated here. So if f of 1 is 3, then f inverse evaluated at 3 gives me 1. So I'm evaluating f inverse of f of x, and so it's basically these are kind of cancel each other is what you can really sort of think about. They're canceling each other, leaving you with x, and these canceling each other here, leaving you with x. It's kind of the best way to think about it here. Okay. The other thing I want to mention is, in order for a function to have an inverse, I'm going to go ahead and write this down. In order for f of x to have an inverse, it must be a one-to-one function. It must be a one-to-one function. Okay, what does that mean? Okay, let me show you by example. Example is much better than just talking about this here. Okay, you know what a function is, right? We've already talked about that. Here is a line. You know a line is a function because the vertical line test. You know that you can go through here, and every point here there's only one value of f of x for every value of x that you put in there. So you know it's a function. Okay, that's a vertical line test. The horizontal line test is basically when you run it through like this, a horizontal line. If you only cut the function in one place, then it's called one-to-one. Okay, so this is a one-to-one function. Okay, let's look at some other examples, and I'll show you of some functions that are not one-to-one. Let's say you had this. This was your function. Now, first of all, ask yourself, is this a function? Well, yes, it passes the vertical line test, only cuts one place. But the horizontal line test is failed because it cuts a horizontal line in two places. So this is definitely a function, but it is not a one-to-one function. Okay? It is a function, but it's not a one-to-one function. Okay? And as another quick example, if I had something like this, okay, this passes the vertical line test, so it is a function, but it does not pass the horizontal line test, so it is not a one-to-one function. And finally, if I just wanted to give you one more quick example, if I had something like this, okay, this passes the vertical line test, so it is a function, and it also passes the horizontal line test, so it is a one-to-one function. So it is 1, 2, 1. And it is a function, okay? So the big thing here is when you're looking at trying to figure out if it's a one-to-one function or not, you basically use that horizontal line test, and that tells you that, and it basically implies that a one-to-one function must be, in general, increasing as x increases. So you see here this goes up, here this one goes up. If it kind of goes down and then goes back up, well, you're going to fail that horizontal line test, and basically it means that the function must kind of, in general, increase on its domain, and that makes it one-to-one. In order for a function to have an inverse, it must be a one-to-one function. So this function does not have an inverse. This function does not have an inverse. Only functions that are one-to-one and kind of increase like that have an inverse, and I think you will see why that's the case here in a minute. What would an inverse function look like? Okay, what would an inverse function look like? Or what does an inverse function look like? Okay, well, let me go ahead and draw a graph here. Okay. Let's say this is the function f of x, okay? And let's say this point right here is 0, 1, okay? The inverse function, by definition, is simply the mirror image of f of x over the line y is equal to x, which is just basically the line that goes 45 degrees here through the xy plane. So in this case, the inverse function looks like this, okay? F inverse of x, and this point is 1, 0, okay? So these are inverses, and basically the inverse function is always going to be flipped over, and you can see why it has to kind of, in general, increase so that when you get an inverse, you get a nice clean function, inverse, okay? And it kind of makes sense that this is flipped over the line y equals x, because look what happened here. This point was 0, 1, and you flipped it so that it's 1, 0. So it's a mirror image over y equals x, and that's the definition of an inverse. Okay, so the next question is, how do you actually find the inverse? Okay, so I'm going to actually title this, How Do You Find the Inverse Function? How would you actually do that? It's really easy to do, actually. Okay. Step number 1, I'm going to illustrate it by example. Let's say f of x is equal to 7x minus 5, and I would like to find f inverse of x. Okay. So the first step that you actually do anything is you replace this f of x with y. So it's y equals 7x minus 5. So you replace f of x with y. You just do this to make it easier to look at on the eyes. You'll see why in a minute. Okay, very simple. The next thing you do is you flip y and x. So the y you make into an x, and the x you make into a y. So now it's x is equal to 7y minus 5. So you replace x with y and y with x. And this actually is what does the flipping, okay, because we're flipping something here, so we replace x with y. And you do that with every x and y in your function. Okay, the next thing we do is we solve for y. That's the next step here. So what I'm going to do that is I'm going to move this 5 to the other side by adding it over here, and I'm going to solve for y by dividing by 7. So I'm going to have x plus 5 divided by 7 is equal to y, and just putting y on the left, it's going to be x plus 5 divided by 7. So this step is solve for y. Okay? So I've solved for y. And step 5, which is the final step, you just replace y with f inverse of x is equal to x plus 5 divided by 7. Okay? So what you do here is you replace y with f inverse of x. Okay? So you see it's just a few simple steps. It's really not that hard to find the inverse function. All you do is you take your f of x, you replace it with y. That just makes it easier to solve later on. Then you flip x and y, put x wherever y is and y wherever x is. And then you solve for y, and we did this with our algebra. We solved for y, and then we simply replace y with f inverse of x, and that's the answer. That is the function inverse. Okay, now we're going to do some problems. We're going to first look at some graphs, and we're going to tell if the graph is one-to-one. That's the first thing we're going to do. And then we're going to work on some inverses. So the first question is this graph a one-to-one function? Yx, okay, here's the graph. Is that a one-to-one function? Well, first of all, is it a function? Using the vertical line test, it is a function. It only crosses in one spot. Is it a one-to-one function? Use the horizontal line test. Well, it crosses in two spots. So what you would write down is you would say it is a function and it is not one-to-one. Okay. Next problem is, what if I had something like this? Is this a function and is it one-to-one? Okay. Use your vertical line test, and you can see right away it crosses in more than one place, so you would say this is not a function at all. Okay? And then finally, if I had one that looked like this, is this a function and is it one-to-one? Well, you look at your vertical line test, it is a function, because it only crosses in one spot everywhere, and the horizontal line test looks to be passed as well for the same reason. So it is a one-to-one function. So here's a bonus point. Which one of these has an inverse? Okay, well, this one is a function, but it's not one-to-one, so it cannot have an inverse. This one is not a function at all, so it definitely can't have an inverse. This one is the only one that's a function and is also one-to-one, so it does have an inverse. Okay, so the next problem we're going to do, the problem says show that these two functions are inverses of one another. So if I have f of x is equal to 3x minus 7, okay, and g of x is equal to x plus 7 over 3, what I'm trying to do is prove that these are inverses of one another. And if you remember back to the cancellation properties, a function is an inverse of another function if f of g of x is equal to x. That is basically the test. So you take one function, you plug it into the other, and if you get x back, then those are inverses of each other. So I take g of x and I plug it inside here. So what I'm going to have, I'm going to put a question mark, see if it equals x. I'm going to have 3 times x, but x is now equal to g of x. So x plus 7 over 3 minus 7. Okay? And that is going to be equal to, 3 is going to cancel with 3, so I'm going to get rid of that, because 3 divided by 3 is 1, so I'm going to have x plus 7 minus 7, so it's going to equal x. Yes, these are inverses of one another. Because I plugged this in and I got x back, these two functions are inverses of one another. Okay? That's exactly what that means. So let's do another problem like that. If I had f of x was equal to x squared minus 9, and g of x was equal to square root of x plus 9, and the question is, are these two functions inverses? So all I have to do is look at f of g of x and see, is it equal to x after I simplify everything? So let's do that. Let's take g of x, let's plug it in here. So square root of x plus 9 squared minus 9. What is this equal to? Okay, this is equal to Square of a square root cancels. Okay, so that goes away, and I have x plus 9 minus 9. So it equals x. Check yes, these are inverses of each other. Okay, those are inverses of each other. And we'll do one more. We'll say f of x is equal to 1 over x minus 2, and g of x is equal to 1 over x plus 2, like this. Are these functions inverses? Let me try f of g of x. Let's see what this equals. Okay, let me take g of x, let me plug it in here. 1 over, plugging this entire thing down here, 1 over x plus 2 minus 2. You can see I've taken all of g of x and I've plugged it down here, and now I just need to simplify it. 1 over, let me just strip away the parentheses, 1 over x plus 2 minus 2, which is going to equal 1 over x. 2 minus 2 is 0, so this just kind of disappears. And then 1 over x, you just take the bottom fraction, turn it over, and put it up there. It's just going to be equal to x. So because f of g of x is equal to x, those two functions are inverses of one another. Now in the next type of problem, I'm going to give you a function and ask you to calculate its inverse using the technique that we talked about just a few minutes ago. So if f of x is equal to 3x plus 7, what I want to do is find f inverse of x. So the first step is to replace f of x with y. Y is equal to 3x plus 7. The next step is to flip x and y around. So I'm replacing y with x and x with y. That's all I did. That actually does the flipping. The next step is just to solve for y. Okay? So moving the 7 over, x minus 7 is equal to 3y. I subtracted 7 from both sides and moving it over there. Okay? And then the final step, and I'm going to kind of flip this equation around here, is I'm going to say y is equal to x minus 7 over 3. I divided both sides by 3, getting rid of it here. So x minus 7 over 3 is there. And then the last step is to replace y with f inverse of x, because that's what y is equal to. And this is the inverse, x minus 7 over 3. This is the inverse function of this function here. Okay, so it's really not that hard. Let's say you had f of x is equal to square root of 2x plus 7, and I wanted to find the inverse of that function. So again, the first step, replace f of x with y. Y is equal to the square root of 2x plus 7. Okay? Next step is replace x and y and flip them. X is equal to the square root of 2y plus 7. All I did was flip the location of x and y. Now I need to solve for y, so I need to start isolating y. First thing I'm going to do is get rid of this radical, so I'm going to square both sides because the opposite of a square root is a square. So I'm going to have x squared over here is equal to 2y plus 7. I totally got rid of the radical because the opposite of a square root is a square, and I had to square the left side. Okay? Now I'm going to move the 7 over here. X squared minus 7 is equal to 2y. Okay? And finally, solving for y. Y is equal to x squared minus 7. X squared minus 7 over 2. That is basically the answer. And then the very final thing you do is you replace this y with f of minus 1, which is the inverse, is equal to x squared minus 7 over 2. Okay? So that's all you do there. So it's a pretty straightforward process. Not terribly difficult. You just you replace this with y, you flip the variables around, and you solve for y. We'll do one more like this, and what'll be f of x is equal to 5x cubed minus 7, and we want to find the inverse. Okay? First thing is we replace f of x with y is equal to 5x cubed minus 7. Next thing we do is we flip x and y. We put x where y is and y where x is. That's all we did there. Next thing is we want to solve for y. So I begin by moving the 7 over here. X plus 7, I add it to both sides, 5y cubed. add it to both sides, get rid of the 7 over there. Okay? Finally, I want to get y cubed by himself, so I'll say y cubed is equal to x plus 7 divided by 5. I just divided both sides of the equation by 5. I got rid of it over here. 5 divided by 5 is 1, and this over 5 is what I have here. And then finally, y is going to equal the cube root of x plus 7 over 5. It's a cube root because I'm trying to take the cube root of both sides to get rid of this cube, because the cube root of a cube, it just cancels. Okay? And then the final thing is to replace y with f of negative 1 of x is equal to x plus 7 over 5. So that's all I had to do there, x plus 7 over 5. And don't forget that the entire thing is cubed rooted. Okay, so all I did is I take the y and I replace it with this guy right here. Pretty simple process. You replace f of x with y, flip the variables around, solve for y, use the rules of algebra, and you'll find these inverses. So in this section we've covered the topic of inverse functions, which are special functions that kind of cancel or kind of annihilate, I guess you'd say, the original function. They're sort of like an opposite. In graphical forms, it's flipping that function over the line y is equal to x, okay, which is that diagonal line like this. So if you graph an inverse and its function on the same plot, you'll see that they're a mirror image of each other flipped over that line there. And they're very useful in math. They're very useful in other areas of math to be able to calculate a function inverse. And you can see here the technique really isn't all that difficult.